Alright, kiddos, I hope you guys are doing well. I am going to go over the homework 2 one-dimensional kinematic problems. If you haven't done these already, you can follow along and do these and still get some of the points. The main emphasis with this is that attempt them on your own, you're going to get more points. If you wait for me to do this, you're only eligible for half the points as the late penalty has gone by. However, I need you all to learn to do this. So please do this, show your written work, and follow along with me. And again, it's going to be this assignment, homework 2, one-dimensional kinematics. I'm going to take little pauses here and there in between the problems. So this is the very first one. It says, the largest acceleration is achieved by... and then what I want you guys to think about here, remember when we had, that's the x-axis, or the y-axis, excuse me, this is the x-axis. And remember that this was how many meters had gone by, and this is the amount of time that had gone by. Remember we talked about that in class with the cow races. Now, what was it that we said we wanted our cows to do? Because remember I told you it's kind of like the stock market. Like, that's some growth and that's good. That's also some growth. You bought this at a later time and it went up at a steady rate. However, what if you bought some stocks and they went straight up like that? They covered a lot of distance in a really short amount of time. Because as you can see here, that is a short amount of time and it covered a lot of position. So the answer is B, a large change in velocity over a short time interval. I hope that kind of makes sense. Again, remember I was using that stock market analogy for how you want to see your stocks go straight up. Again, this growth is good here, but you want this. So this is a constant acceleration over a long time period, whereas this is a really fast acceleration in distance over a short amount of time. So hopefully that makes sense to you. Okay, so the second one says following graph represents the position of as a function of time for a moving object. Use this graph to answer question 2 and 3. So question 2, which is true of the following? Well, look at this. You can actually use this little point right here where you see that it has been, oh, my eyes are so bad, 8 seconds and 40 meters. So remember, speed equals distance divided by time. So your speed, what is your distance? Your distance is 40 meters. And your time is 8 seconds. So 8 times 5 is 40, so it's 5 meters per second. So it says the object increases its velocity, the object decreases its velocity, the velocity stays unchanged, and that is the answer that you want to go with here, because as you can see, it is just a steady velocity. It is flat. It is not, say, a velocity, say it was like this, and it goes up, and then it pauses, and then goes up again, and then pauses. It just goes straight, steady. And then what is the velocity of the object? We already worked that out right here. It is 5 meters per second. All right, so let me pause and get the next problem set up. So this is going to be problem 4 and 5. Oh, sorry. Where's it? Hey, okay. Sorry about that. I'm still getting used to this thing. Okay, so a truck travels east with an increasing velocity. Which of the following is the correct direction of the car's acceleration? Oh, excuse me. So remember, you're looking at a map, you say north, south, east, and west. So obviously it's going to be headed east. Now it says with an increasing velocity, so you're probably initially going to be thinking that it is B. However, remember that speed increases means velocity and acceleration are going to be pointed in the same direction. So says speed increases. Means velocity and acceleration. All right, so with that, speed increases means that velocity and acceleration are going to be in the same direction, and we're headed east. So this is actually the answer right here. It is A. Now on the second one, let me block this off so there is no confusion. As to what belongs where, we'll do this one in purple. On a ride called the Detonator at Worlds of Fun, Kansas City. Passengers accelerate straight downward from 0 to 45 miles an hour in 2.2 seconds. What is the average acceleration of the passengers on the ride? Oh, excuse me for that yawn. First thing I want you to note is that there are two Kansas cities. There's Kansas City, Kansas, and Kansas City, Missouri. I only know that because I used to be a directory assistance operator, but that's just a fun little fact. Okay, with this, I would write out your formula, write out what you know. So what do you know? You know that V naught or V initial is what? 0. 0, what units? Miles per hour. Oh, that is such a horrible one. Okay. Now, V final is 45 miles an hour. And it does this in 2.2 seconds. So that is your time. It says, what is the average acceleration? Well, what do we know? What do we have? We know that our formula is A equals V final minus V naught or V initial. Remember, V naught, V initial, same thing, over the time. So all we're going to do is plug and play. So A equals V final is 45 miles an hour. Minus 0 miles an hour over my time, which is 2.2 seconds. So when you subtract that out, you get 45 miles an hour over 2.2 seconds. Give me 1 second. Let me turn the lights back on in the room because they always go out and get my... Okay, sorry about that. So with this, once you divide that out, you are going to end up with 20.45 miles per hour over seconds. So that is the answer for that one right there. Now we are going to go to... Let's see, that was number 5. We'll do number 6. Yes, this is what I am doing in between. I swear I've done that. Okay, hold on. Okay, sorry about that. So we'll do number 6. It says an object is traveling at a constant velocity of 15 meters per second when it experiences a constant acceleration of 3.5 meters per second squared for a time period of 11 seconds. What will its velocity be after that acceleration? So with this one, again, go with what you have. So with this, I see that it's traveling at a constant velocity, so that is its initial velocity. So you could write that as V naught. You could also write it as V initial. I will just stick with V naught for the moment. So V naught is 15 meters a second. And then you said, or not you said, it said, when it experiences a constant acceleration at 3.5 meters per second. So it says it gets an acceleration 3.5 meters per second squared. And next it tells you that it has a time of 11 seconds. And I'm sure, as you can already see, we only have one other thing we're going to need for our formula, which will be V final, because that is this after right here. When you think of it, when you go on a race, or you're in a race, after the race, you know what your final time was. Think of it kind of like that. So we're going to say our acceleration equals V final minus V naught over the time. Now you're probably wondering why I didn't plug the numbers in there. Well, here's one of the things that makes this a lot easier when you're in physics, is you want to go ahead and get your variable that you are solving for alone first before you plug the numbers in. It makes it easier. So I want to go ahead and get VF alone and then plug my numbers in. So what am I going to do with that? I will say x equals V final minus V naught over time. So I'm going to multiply by time on both sides. What that gives me is A times T equals V final minus V naught. So obviously I'm going to add V naught, add V naught. And from there, let me put this in a different color. I'm going to have AT plus V naught equals V final. With that, I'm just going to have to erase some of this here in a minute to get myself. I'm going to plug everything in, so I have a 3.5 meters per second squared times 11 seconds plus what? What do I need to put in? V naught, 15 meters a second. All right, so from here you will grab your calculator. We'll say 3.5 times 11 is 38.5 plus 15 is 53.5. 53.5 meters per second. That is the answer for that one. Now you are probably wondering about these units here along with these units. Think of it like this: 3.5 meters over top of seconds times seconds, and then I have 11 seconds up here. So remember when I was teaching you guys dimensional analysis, this is where this really helps a lot, because since I have a second here and a second here, I can cancel those out. And when I'm doing this operation right here, 3.5 times 11, let me do that again because I didn't memorize what it was. It's 38.5 meters, because I'm left with this meter over seconds. Meters divided by seconds, or the way we are writing it, 38.5 meters per second. And then we are adding that to 15 to get 53.5 meters per second. So that is how you do that one. And again, when I first started taking physics, this part here, adding, because you're like, dude, you can't add those. They're not like terms. That is why you can do that, because you can cancel those out like that. And dimensional analysis really helps with that. So let me see, I'll just go ahead and do this one on here. Probably would have been easier if I would have just hit clear canvas, but then I got to reinsert problem number 7. There we go. All right. An object is moving at a velocity of 23 meters per second. It accelerates to a velocity of 85 meters a second over a time of 8.3 seconds. What acceleration did it experience? Again, we're going to do the exact same thing we always do. Well, just let me select this and get rid of it. Maybe, maybe not. Woo, what do you know? All right, move this over here so we got a little more room to work with. So what do we have? What are we looking for? Well, this is obviously an acceleration problem because it tells us right there. And we know that is acceleration equals v final minus v naught, or v initial over time. Let's go ahead and fill in what we have. So we want to find this, the acceleration. What do we have? Well, v final is what? It accelerates to a velocity of 85 meters a second. It says it's moving at a velocity of 23 meters a second, so that is v naught, because that's what it started at, or that's the starting speed it gave us. And then it gives us a time of 8.3 seconds. And with this one, you don't have to move anything around because A is already alone, so you can just, again, plug and play. Oh my gosh, those are the best kinds of gaming systems because you don't have to do anything. You can just plug them in and play your video games. That's 23 meters per second in really nasty handwriting for 8.3 seconds. Okay, so from here I will say, what is 85 minus 23? 62. 62 meters a second over 8.3 seconds. And you should end up with 7.47 meters per second squared. All right, so 7.47 meters per second squared. That is the answer for that one. Now we are going to go to number 8. This one, an object initially at rest. Remember what I told you guys about when you see rest. That just means 0. Experiences an acceleration of 9.8 meters per second squared. How much time will it take to achieve a velocity of 58 meters per second? So with this, it sounds tricky, but it's really not too bad. You have to say, what am I looking for? Because it says how much time, and then you kind of plug everything else in. So we say acceleration equals v final minus v initial, or v naught, over time. And we want to get time alone because that's what we're looking for. We also want to list what we have and what we're looking for. So an object initially at rest. So V naught, our initial one, is 0 meters per second. V final is 58 meters per second. And then it says experiences an acceleration of 9.8 meters per second squared. That was supposed to be an A, but it looks really bad, but you guys know what it is. Anyway, 9.8 meters per second squared. So I have my information. I want to go ahead and get T alone. So I'm going to multiply by T, and I will end up, well, we'll just do it over here. T times A equals VF minus V naught. Now I want T alone, so I'm going to divide by A, so I end up with T equals V final minus V naught over A. Now I am going to plug and play. So T equals V final, which is 58 meters per second, minus 0 meters per second over 9.8 meters per second squared. So 58 minus 0 is 58. So it's 58 meters per second over 9.8 meters per second squared. Let me grab my calculator. And I end up with 5.92 seconds. Okay, that is really, really messy. Sorry about that. 5.92 seconds. And just real quick, if you're wondering how I ended up with just seconds when you're dividing all this change over here, think of it this way. 58 meters per second divided by 9.8 meters. Meters per second squared, so that's seconds times seconds, so you can cancel this one and cancel this one, and so you end up with just this one. So that is why it is 5.92 seconds. All right, so that is all of those problems. I hope that that helped you out. If you have any questions, just make sure that you let me know. Otherwise, go ahead and work all these problems out on paper. Take a picture or a scan of your written work where you have worked these out and submit it into the assignment. If you can do that, I can still give you half the points. The reason I need you to write these out is because by you writing them out, you are practicing them and you are learning how to do them. So although I am guiding you through the steps, you are doing it yourself. It's kind of like this right here where this guy is skateboarding down this hill. It's like I'm showing you how to skateboard, but then you're getting on and practicing it yourself after you've seen somebody else already do it. I don't know, kind of think about it that way. Anyway, hope that helps. Have a good day, guys.